Now, to look at this piece of code and to think about what it means to have a critical reading of code and to try to understand this in a multifold way, right? Something that exists in the context of this, the most popular single model of computer, best-selling single model of computer ever, Commodore 64, manufactured beginning in 1981 as part of this home computer era in which people had many platforms available, TI, Apple, Atari, and coming from various traditions of calculators and business machines. Commodore Business Machines is the company that made this. Jack Tramiel, a Holocaust survivor, putting that company together and making it a success. This is the piece of code itself. And let's see. One of the things to try to figure out what it does would be, of course, we want to know what, we see that, we guess that RAND 1 gives us something between 0 and 1, which in fact it does the same thing as RAND 50 or RAND 200, because it's only the sign of the argument to RAND that matters. But nevertheless, RAND 1 does give us a number between 0 and 1. And so that has the effect of selecting either character 205, when that's truncated, or character 206. And what do those codes mean? Well, that's important to figure out what the visual effect would be. Well, here they are. Mm-hmm. They're what you might think of as a backslash and a forward slash, but they're actually not those characters. They're similar characters that are sort of a left-leaning diagonal going from upper left to bottom right, right-leaning diagonal. So let me actually mention a few things about this program. You know, one of the things people are very quick to seize on what Michael and I, in writing about obfuscated code and weird languages, call, you know, the play that is available in a programming language. You could write a particular program many different ways. So if you choose to write it one way, if you, for instance, use reverse Hungarian notation because your company standards for coding say that you will do that, right? That's a particular choice, and that reveals something about the institutional context in which you made a program. If you choose to write another way, for instance, choosing deceptive names for variables that make it hard for other programmers to understand them, perhaps for a playful purpose, that's revealing a different context and a different sort of value that you have in writing that program. In this case, there's almost nothing. There's almost no play in that there are no comments, there are no variable names. So people can't choose to write something else. In fact, the one choice you could make is you could omit the spaces if you wanted, because in Commodore 64 BASIC, spaces are optional. A result of that is that variable names cannot contain keywords as any substrate. So you couldn't have a variable named printer because it would parse that as being the command print. So there's very little along those lines, but I guess you could say that because there's a space between tin and print and char, this has been written with some concern for a human reader to look at it later on, right? It wasn't someone who was trying to write the smallest number of characters possible, but rather a concise program that was legible and understandable. There's a lot of things I could talk about related to just the history of the basic programming language and these particular keywords, how this is written. I mean, I guess the first thing you might think if you were looking at this line is, why does it begin with 10? Any ideas as to, don't answer. Any ideas as to why does this program begin with the number 10?
Because it's in BASIC?
Well, it's written in BASIC, yeah. So that number 10 has a function there, which is that it's a line number.
Yeah, I was going to say, in BASIC, don't you have to call your lines? Yeah. Like each line you have to give a 10.
Well, and it's interesting, not in every version of BASIC, actually. In Visual Basic and Quick Basic, you can omit line numbers. But in the original Dartmouth BASIC and Commodore 64 BASIC, every line does have a number. Actually, that has more to do with the need to edit a program on a print terminal than it does with BASIC itself, because you don't need to label every line unless you're jumping to every line by referring to it with goto or goso. So, but if you want to edit that line later on, you better be able to quickly refer to it, to list 10 or list 250 or whatever else, to be able to edit it. So that answers why there is a number at the beginning of this, but why is it number 10?
You always use 10 so that you have room to add lines beforehand in case you need lines beforehand.
So already there's a trace of this programming practice in which you may wish to add lines before this line. It would be so onerous in a one-line program to like manually renumber it from 1 to 7 or something, right? So obviously you prefer to give it a line number like 10. One of the examples of this program that we find in print has, which I'll show in a bit, has 8 instead of 10 actually, and also ran 8 since you can do that also. How interesting. We could rhapsodize about why that might be so. But 10 is much more conventional, and so it shows that programs exist in context of practices where people choose meaningfully to put a number like 10 at the beginning. Now, also, though, it shows that programs are dynamic objects, that people might add to them and modify them and change them. So this is not an artifact that is just to be run and you're to look at the output, but you're also possibly going to modify it in various ways. And the reason, because that number is 10 rather than 1, that is allowing you to modify it a little bit more easily. That's a concession to the fact that that program might be modified. So there's a sign of that even in this tiny space of characters right here. What about the print? What does print do?
Character to the terminal.
It prints the character to the terminal. It actually, on a Commodore 64, doesn't do that. It displays something on a cathode ray tube screen, or it would have in 1981. So, I mean, you could have called it display, but actually there's another, if you want to print, you have to give another argument. You have to give print and then a number after it as to which port you want to actually send that data out on to go to the printer. Of course, in 1965 in Dartmouth, when BASIC is being used, they're using print terminals. So when you use the print command, it did literally print something. So here we have a trace of history that's visible in this program already, even though it's been 25 years basically since, or actually less than 15 years by the time the C64 is invented and after the time that BASIC is invented. But already we have this baggage of a previous display system that's been used that prints things out, and so we have a keyword that is called print, even though it is not printing. It is displaying something on the screen. Right? So there's a great deal. This is our interest in this program, has paid off in finding that even in tiny pieces of code, which if we were distracted perhaps by looking more or less exclusively at comments and trying to imagine the way that programmers work from that, we'd be overlooking, we find things about history. Char string is a good place. Okay. So why char string is how I pronounce it, and I think how Commodore 64 programmers in general would. But that right there is that symbol?
$sign.
The $sign. So what is it about the computer that it would have a $sign on the keyboard that we would want to appropriate and use in a different way, not in the way that it's intended? Perhaps a computer is originally made for commerce. And it's American. That's why it has a $sign. Actually, the Commodore 64 also has a pound sign, Great British Pound, available because they're interested in exporting it to the UK, obviously. But it doesn't have a symbol for the Japanese yen. And like I imagine all of the computers that we all have, it doesn't have a multiplication sign. Right? If you want to do multiplication, the way you indicate that on your computer is by typing an asterisk, which is a typographical mark for indicating a footnote. Why, if the computer is about calculation, why is it that we have to appropriate typographical symbols for use as mathematical symbols? Because they're not provided by the character set that we have. Well, because we have perhaps an interesting device with a complex history that was doing things like tabulating the census, adding up money, but not doing multiplication or other mathematical operations. Okay, so those are all fun things. I want to